When you stand beneath a massive bridge stretching across a roaring river or connecting two distant cities, it's easy to admire the final masterpiece. But what most people never see is the sheer scale of machinery and engineering power required to bring that structure to life. Behind every towering suspension cable, every steel beam, and every concrete pillar lies an army of machines so enormous, so powerful, that they almost seem unreal. This is the hidden world of the biggest bridge construction machines on Earth, where oversized load trucks carry pieces of infrastructure larger than houses, where cranes lift entire bridge sections in a single move, and where engineering meets raw mechanical force in ways that push the limits of possibility. The story of bridge construction begins long before the first piece of steel is lifted into the air. It starts with planning, precision, and logistics on a scale that feels closer to military operations than traditional construction. Engineers design bridges that can span kilometers, withstand earthquakes, resist extreme weather, and support the weight of thousands of vehicles every single day. But once those designs are complete, a new challenge begins. How do you actually move and assemble something so massive? That's where oversized load trucks come in, machines built not just to transport cargo, but to carry entire sections of bridges that weigh hundreds or even thousands of tons. These trucks are not ordinary vehicles. They are multi-axle giants, often stretching longer than a football field when fully extended. Each wheel is controlled independently, allowing the entire platform to move in ways that seem almost impossible. They can rotate on the spot, slide sideways, or carefully inch forward with millimeter precision. This is crucial when transporting bridge segments through tight construction zones or placing them in exact positions where even a small mistake could mean disaster. The drivers of these machines are not just operators. They are specialists trained to control some of the most complex vehicles ever built. Imagine a single steel beam, longer than a city block and heavier than dozens of cars combined, being transported through a narrow construction corridor. The truck carrying it moves slowly, sometimes at walking speed, guided by a team of engineers communicating constantly. Every movement is calculated, every turn is planned in advance. In some cases, entire roads are temporarily shut down just to allow these machines to pass. It's not just transportation, it's a carefully orchestrated operation where timing, coordination, and precision must align perfectly. But moving bridge components is only one part of the equation. Once the materials arrive on site, another set of incredible machines takes over. Among the most impressive are the giant crawler cranes, towering structures mounted on tracks instead of wheels, capable of lifting weights that defy imagination. These cranes can hoist entire sections of a bridge high into the air and hold them steady while workers secure them into place. Watching one of these cranes in action feels like witnessing a mechanical giant at work, its long boom reaching into the sky as it slowly, almost gracefully, lifts loads that would crush ordinary machinery. Some of the largest bridge projects in the world rely on specialized lifting systems that go beyond traditional cranes. Strand jacks, for example, use high-strength cables to lift massive loads vertically with incredible precision. These systems can raise entire bridge decks, piece by piece, ensuring perfect alignment. The process is slow, methodical, and incredibly controlled, often taking hours or even days to complete a single lift. But this level of precision is what makes modern bridge construction possible, allowing engineers to build structures that were once considered impossible. Then there are launching gantries, machines that almost look like bridges themselves. These massive structures are used to construct bridges segment by segment, especially in areas where building from the ground up is not practical, such as over deep valleys or busy highways. A launching gantry moves forward along the bridge as it is built, placing each new segment in position. It's like watching a bridge build itself, with the machine acting as both the builder and the platform. These machines are engineering marvels, capable of supporting enormous weights while maintaining perfect balance hundreds of feet above the ground. In many modern projects, entire sections of bridges are built off-site and then transported to their final location. This method, known as modular construction, has revolutionized the industry. It reduces construction time, improves safety, and allows for higher quality control. But it also creates a new challenge. How do you move a fully assembled bridge section that weighs thousands of tons? The answer lies in self-propelled modular transporters, or SPMTs. These are some of the most advanced oversized load trucks in existence, capable of carrying loads that seem almost impossible. SPMTs are made up of multiple modules, each with its own set of wheels and hydraulic systems. These modules can be connected together to create a platform of almost any size. The result is a vehicle that can distribute weight evenly across dozens or even hundreds of wheels, allowing it to carry extremely heavy loads without damaging the ground beneath it. What makes these machines truly remarkable is their ability to move with incredible precision. Operators can control each wheel independently, allowing the entire platform to move in any direction. This level of control is essential when positioning massive bridge segments with millimeter accuracy. One of the most breathtaking moments in bridge construction comes when a massive section is finally moved into place. The transporters move slowly, guided by engineers and supported by cranes or lifting systems. The entire operation can take hours, with every movement carefully monitored. As the section approaches its final position, the tension builds. Perfect timing and coordination, the piece is lowered into place, completing another part of the structure. It's a moment of triumph, not just for the machines, but for the entire team behind the project. Bridge construction often takes place in some of the most challenging environments on Earth. From deep rivers and coastal waters to mountainous terrain and urban centers, each project presents its own unique obstacles. In these conditions, the machines used must be not only powerful but also adaptable. Amphibious excavators, for example, can operate in waterlogged areas, helping to prepare foundations in places where traditional equipment would struggle. Meanwhile, specialized drilling rigs can bore deep into the ground, creating stable foundations for massive bridge supports. Weather is another factor that cannot be ignored. High winds, heavy rain, and extreme temperatures can all impact construction. The machines used in these projects are designed to operate under these conditions, but even the most advanced equipment has its limits. Engineers must constantly monitor weather conditions and adjust their plans accordingly. In some cases, entire operations are paused until conditions improve, highlighting just how delicate the balance is between human ambition and natural forces. Despite all the challenges, modern bridge construction continues to push the boundaries of what is possible. Advances in technology have made machines more powerful, more precise, and more efficient than ever before. Computer systems now assist operators in controlling complex equipment, ensuring that every movement is accurate. Sensors monitor loads in real time, providing critical data that helps prevent accidents and improve safety. Safety is a top priority in any construction project, but in bridge construction, the stakes are even higher. The size and weight of the materials involved mean that even a small mistake can have serious consequences. That's why every aspect of the operation is carefully planned and executed. Workers undergo extensive training, and strict safety protocols are followed at all times. The machines themselves are equipped with advanced safety features, from automatic braking systems to load monitoring sensors, ensuring that everything operates within safe limits. As cities grow and infrastructure demands increase, the need for larger and more complex bridges continues to rise. This, in turn, drives the development of even more advanced construction machines. Engineers are constantly innovating, finding new ways to improve efficiency and reduce environmental impact. Electric and hybrid construction equipment is becoming more common, offering a cleaner alternative to traditional diesel-powered machines. At the same time, automation and robotics are beginning to play a larger role, with some tasks now being performed by remotely operated or even fully autonomous machines. Looking to the future, it's clear that the world of bridge construction will continue to evolve. The machines will become even more powerful, the technology even more advanced, and the projects even more ambitious. But no matter how much things change, one thing will remain the same: the incredible combination of human ingenuity and mechanical strength that makes these projects possible. Every bridge tells a story, not just of connection and progress, but of the machines and people that made it possible. From the oversized load trucks that carry massive components across long distances, to the cranes and gantries that lift them into place, each piece of equipment plays a vital role. Together, They form a system of engineering that is as complex as it is impressive. So the next time you cross a bridge, take a moment to think about what lies beneath the surface. Think about the giant machines that worked tirelessly to bring it to life, the precision required to assemble it, and the sheer scale of the operation. Because behind every bridge is a story of innovation, determination, and the incredible power of modern engineering. A story driven by some of the biggest and most impressive machines ever created. If you enjoyed this deep dive into the world's biggest construction machines, don't forget to like, subscribe, and hit the notification bell, because the next video will take you even deeper into the most powerful engineering marvels on Earth.